Alright, this is the 9.3 and 9.4 podcast together. The 9.3 is a very short introduction into mechanical energy. So in this section we're going to talk about the two forms of mechanical energy very briefly: kinetic energy and potential energy. So when we're talking about mechanical energy, let's look at a couple examples here. When work is done by an archer in drawing back an a bowstring, the bent bow acquires the ability to work on an arrow. When you lift the heavy ram of a pile driver, the ram acquires the ability to work on the object it hits when it falls. When work is done to wind a spring mechanism, the spring acquires the ability to work on various gears to run a clock, ring a bell, or sound an alarm. So something has to be acquired that enables the object to do work, and it can be compressing atoms, it could be separating things that are attracted, or it can be rearranging electrical charges which then will want to move as a result of the rearrangement. So this property that enables something to do work is energy. Energy is the ability to do work. It's also measured in joules, just like work. Mechanical energy is due to the position of something or the movement of something. So our two forms of mechanical energy are going to be kinetic energy and potential energy. Let's look at potential energy. There are three types of it: elastic potential, chemical energy, and gravitational potential energy. So energy that is stored and ready to go is called potential energy. It has the potential for doing work, and this could be done by the virtue of the position of an object. Let's look at elastic potential energy. Remember the bow that we talked about in with the bow and arrow. If you pull the bow back, now we're stretching the string, and that's like an elastic. It's going to snap back. Rubber band has potential energy because of its position. It's going to snap back. So these are potential energy, are elastic potential energy. Here's a woman pulling back a bow, and she's applying a force on that arrow over a distance. It's only maybe about a few centimeters, but she really has to pull on that bow. So she is creating elastic potential energy in the bow, and that energy then is going to be transferred to the arrow. Chemical energy is also potential energy, and this is something you can see at the subatomic level, and it has to do with the chemical process or chemical change taking place, and we see this in fuel such as gasoline, or maybe in batteries. So gravitational potential energy is when you lift things against Earth's gravity. For instance, the water in a reservoir has gravitational potential energy. It has the potential to flow back down towards the Earth, down a slope, and maybe go through a dam, and a generator in a dam. The pile driver has the potential energy, as because it's raised up. You raise a book above a table, that has potential energy. It has the potential energy of coming down and doing work on something underneath, smashing something on the table, or making noise. Excuse me. To find the amount of gravitational potential energy, it's a rather simple formula. It's going to be the weight times the height of the object. And we all know that weight is a product of mass times gravity. So potential energy can be mass times gravity, which is weight, times the height that object is elevated. Here we get a picture of somebody being lifted up, and the woman is exerting a force, the weight, which we know is mass times gravity, and it's this gentleman's mass plus gravity times gravity pulling him down, and she's lifted him, well, maybe, I don't know, maybe that's 6 feet high, maybe it's 2 meters high, so that would be the height. and that is the potential energy that she has given to him by lifting him up. Now, potential energy, we have to decide what the reference level is. Reference level. This is another frame of reference. If I lift something above a table, it has one amount of potential energy. If I lift it above a floor, that's a different amount of potential energy. I might be holding the object at the same height, but it depends what I think is the reference level. If I hold a book above a table, that's one amount of energy. I hold it above the floor, that's a different amount of energy because the height is different. The heights are different between the table and the floor. Let's look at these examples here. This boulder has been lifted it's a 100 Newton boulder. It's been lifted 2 meters, so 100 times 2 meters is 200 joules. We can push it up a ramp, and we only need to use 50 newtons of force to push it up that ramp, but we got to push it up a 4-meter ramp, so that's 4 meters. 50 newtons of force times a distance of 4 meters is still 200 joules. Or we can bring it up half-meter steps, 4 half-meters. 4 half-meter steps with 100 newtons of force each one of those steps, and you still end up with 200 joules. Let's look at another example of gravitational potential energy. What you would have is a water in a reservoir, maybe in a lake, sometimes the man-made lake if you have a dam, and you're going to convert that water into electrical energy, and the power station will often use a little trick where they move the water back up from the lower reservoir up to the reservoir, and they do that at night. So let's think about this. You lift a 100 Newton boulder 1 meter. How much work is done on the boulder? Well, that's going to be 100 newtons times 1 meter, so that should be 100 joules of work. The power, how much power is expended if you lift the boulder in a time of 2 seconds? We'll take that 100 joules of work, we'll divide it by 2 seconds, we end up with 50 watts. And then how much potential energy it has? Well, related to its starting position, it's going to have 100 joules of potential energy. We lifted it 1 meter with a force of 100 newtons, so it's going to be 100 joules of work. The amount of work we put into the boulder is also going to be its gravitational potential energy. So 3 examples of potential energy. We had elastic potential energy, chemical potential energy, and gravitational potential energy.